In this video, we're going to be talking about 45, 45, 90 triangles. And so in this one, in a 45, 45, 90 triangle, which just means that our angles are 45, 45, and 90, the hypotenuse is the square root of 2 times as long as each leg. And so you notice here, since we have 45 and 45 degree angles, that the opposite sides are actually equal. So our legs are going to be the same length. In other words, they're going to be congruent. And we see that with these triangles, that the hypotenuse is going to be that leg times the square root of 2. And so the equation that we get here is hypotenuse is equal to leg times the square root of 2. So let's go through some examples. So here I want to find the value of x, and I'm going to write my answer in simplified radical form. So first off, I like to go ahead and label my hypotenuse, and so that is going to be the opposite of my right angle. And here I notice that I can use my theorem just because I see that I have 45 of 45 and 90 degree angles in this triangle. So that means I'm going to be using that theorem. And so I can go ahead and write that equation. So I know that the hypotenuse is equal to the leg times the square root of 2. Well, my hypotenuse here is x, so I have x is equal to the leg, which is 8, times the square root of 2. Look at that, I can't simplify that further, so that means that is my answer. Okay, let's look at another one. So here I see I have a right triangle, I have a 45 degree angle here. Nothing's written over here, but since this is 45, this also has to be 45. Next I'm going to label my hypotenuse. So I see that the 5 root 2 is opposite of my right angle, so that is my hypotenuse. And so I know for this theorem that the hypotenuse is equal to leg times the square root of 2. Plugging in what I know, I have that the 5 square root of 2 is equal to x square root of 2. And then solving for x, I'm going to divide both sides by the square root of 2. And I see those cancel to get that 5 is equal to x. Okay, looking at number 3, I see that no angles are actually written here in this triangle, but I do have a right triangle. However, I notice that both of my legs are the same, making this nice isosceles triangle. So we know that these two angles are the same, and so that means that these have to be 45 degrees, since I need to add up to 90. So I do have a 45, 45, 90 triangle. So I can go ahead and label my side, and I know that opposite my right angle is my hypotenuse. That means that my hypotenuse is x. And so I have the equation that my hypotenuse is equal to the leg times the square root of 2. Plugging in what I know, the hypotenuse is x, so I have x is equal to the leg, which is 10 square root of 2, times the square root of 2. Well, square root of 2 times square root of 2 is 2, so I have x is equal to 10 times 2. So that means that x is equal to 20. Okay, and then we'll try one last one. So here I have a right triangle, and I notice that these two angles are congruent, and I know that from the arc marks. And the only way for those to be congruent is if they're both 45 degrees. So that means I can use my 45, 45, 90 theorem, which tells me that the hypotenuse is equal to the leg times the square root of 2. Well, the hypotenuse is opposite of my right angle, so that means that 16 is equal to the leg, which is x, times the square root of 2. And then to solve for x, I need to divide both sides by the square root of 2. So I get 16 over the square root of 2 is equal to x. However, I am not finished because I have a radical in my denominator. So I need to rationalize my denominator. And to do that, I need to multiply both top and bottom of this fraction by the square root of 2. And so when I do that, I get 16 square root of 2 on top. Square root of 2 times square root of 2 is just 2, so I have 2 on bottom. And then looking at this, I see it can be simplified even further because 16 divided by 2, I get 8. Square root of 2 is equal to x.